All right, synthetic division. It's my favorite type of division. It's a little faster than a long division. When can you use synthetic division? Well, on the last problems that we used long division, I want you to look at the numbers that was on the bottom or the outside. It was 2x, then we had 2y, we had 3x. These are all numbers that didn't just have an x by itself. On the ones that we can use synthetic division, the x on bottom will always just be 1x or 1y. It will only be a number 1 in front of that x. So when you can use synthetic division is when you have a leading coefficient of just 1 in front of your x. If you had a 2x or a 3x or something like that, you have to use your long division. So the first thing you always want to do when you're doing division is make sure that you have your numerator in descending order and there are no missing terms. So that's the case here. We're in descending order. There are no missing terms. Then you look at what is with the x, and whatever this is, you're going to do the opposite of that in a backwards L. So instead of plus 5, you're going to do a minus 5 in a backwards L. Okay? Then I'm going to look at the numerical coefficients on the polynomial on top, and I'm going to write down the coefficients. Now remember, this is an understood 1, so the coefficients are 1, 2, and 10. So our steps so far is to make sure the polynomial on top is in descending order and there are no missing terms. Then you look to see what's with the x, and you do the opposite of that in a backwards L. Write down your numerical coefficients from your polynomial on top, and now we can begin our synthetic division. I'm going to bring down that 1, and make sure you're watching this step. I'm going to multiply negative 5 times 1 and put my answer right here is negative 5. So when I bring down my 1, my first step is to say negative 5 times 1 is negative 5. If it's the same sign you add, different signs you subtract. So I'm going to have a negative 3 for my answer. Negative 5 times negative 3 gives me a positive 15. Same sign, so I'm going to get 25 as my answer. This last answer is called your remainder. Okay, that's synthetic division. So our steps so far have been to make sure that our leading term was a 1 so we could do our synthetic division. We wanted our top polynomial in descending order, add any missing terms if we had any. We looked at what's with the x, and we did the opposite of plus 5 in a backwards L. Then we wrote down our numerical coefficients, 1, 2, and 10. We brought down that 1 as our first step, and then we multiplied. Negative 5 times 1 is negative 5. We subtracted down 2 minus 5, and we got negative 3. Then we multiplied again. Negative 5 times negative 3 and got a positive 15. Added 10 plus 15 and got 25. This last number is our remainder. Now, how do we write this answer in polynomial form? Your answer will always be 1 degree less than what you started with. Since I started with x to the second, this is going to be x to the first. So these numbers are actually the coefficients in front. So if I have 1x to the first, I just have x minus 3, and then my remainder is going to be 25 over that denominator, x plus 5. Now the reason why I did this one first is because we did this one first with our long division also, and so I kind of want to put it side by side so you can see the difference. This is what we did with our long division, and this is what we just did with our synthetic division, and you can see the difference. And you can do any problem that you could use synthetic division with. You can mark them all long division if you wanted to. But remember, you can't do all problems for long division and synthetic. You have to have that leading coefficient of 1 on bottom. So synthetic division in this class will be something that you'll be able to use a lot, because I'll always have the problems picked out where you can use synthetic division on most of them. But the long division, you probably won't use as much as synthetic. When you get to intermediate algebra, I don't think you use long division at all. And even in college algebra, I think you only use synthetic division. So this is something that it would be good for you to learn because it will be easier, faster for most students. And let's do this one example before we stop the video and do another a video for the next ones. So remember what you're supposed to do first. You always want to look and see what's with the x and put it in a backwards L. So opposite of this in a backwards L. So instead of plus 5, I want to do a minus 5 and the backwards L. Then I want to look at the coefficients on the polynomial on top. So it's going to be 1, 12, and 35. So 1, 12, and 35. And always look at the signs that go with that number and make sure they're positive or negative. Okay? Then I want to bring down that 1. And I start to multiply. Negative 5 times 1 is negative 5. And I'm going to subtract down and get 7. Negative 5 times 7 is negative 35. When I subtract down, I get 0. And remember, this is your remainder. Now notice that this time we have a remainder of 0. So that means that I don't have to add that remainder to my answer like I did in the problem above. How do we know how to write our answer in polynomial form? It's always going to be 1 degree less than what we started with. So this is 1 x to the first plus 7. All right, we don't have a remainder on this one, so this is just your answer in simplest form and polynomial form. So again, I do the opposite of what's with the x in the denominator in a backwards L, so negative 5. I bring down that 1, and I have negative 5 times 1 is negative 5. I subtracted down and I got 7. Negative 5 times 7 is negative 35, and when I subtract down, I get 0. And this is my answer in polynomial form because it's always going to be 1 degree less than what we had in a polynomial before it on top. And that's your answer. And we'll pick up with the same stuff in the next video.